Hello, everyone. Great to be here. Fantastic. Some people showing up for the talk. That's amazing to see. So, my name is Emil Eifrem. I'm the CEO and co-founder of a company called Neo4j, which is a leading graph database company in the world. And the framing for today's session is very, very simple, which is the following. 6 months ago, a European fintech CEO casually mentioned to investors that they'd built this AI-native technology platform in-house, which was so powerful that they had used it to kick out both Salesforce and Workday, realizing a bunch of cost savings, but also internal productivity gain. So that happened 6 months ago. A week ago, last week, Tuesday, I guess today is Tuesday, so exactly a week ago, the CEO wrote a blog post detailing the tech stack that they used to pull this off. And today, I'm here to tell you how they did it. But before that, we're going to take a little bit of a step back. We're all here because we feel like there's an innate magical ability in AI. That's why we're, I think, at HumanX. And how can we get that to work for us in our daily lives and in our businesses? But candidly, if you look at the numbers, depending on who you ask, as an industry, we've invested anywhere from hundreds of billions to maybe even $1 trillion in AI. And the ROI, the return on that, is in single-digit billions or maybe tens of billions. And when you ask executives, 75% will say, this is one study, but I've seen many that are very similar, will say that AI is one of the top 3 priorities for them. But only 25% are seeing some kind of value realization from AI. One of the clearest examples that we've seen in our industry from people who get legit ROI from AI is this company Klarna. Raise your hand if you know what Klarna is. Yeah, so most people, it's a European fintech company, pioneered by Now Pay Later. Now they're, I think, more like a neobank, much broader than that. And they've had a number of news cycles based on AI. The first one was over a year ago in February, where they talked about how they launched this AI tool that automated the work of 700 full-time customer service reps, which handled 2/3 of their customer inquiries at a similar satisfaction, higher accuracy, and shorter close time. So that got a lot of buzz, and people talked about, okay, this is real, actual, legit ROI from AI. But then they followed up a few months later saying, you know what, like, okay, that got a lot of buzz, but actually our internal productivity tool, our chatbot for internal organization that we call Kiki, which I think is like Klarna Wiki or something like that, is actually realizing an even bigger change of internal productivity. And then, again, exactly a week ago today, they talked about how their AI platform is used to replace not just Salesforce and Workday, but over 1,200 SaaS tools across the company. So the big question then becomes, how? How did they pull this off? So we started working with Klarna exactly 2 years ago, and we worked with tens, if not hundreds, of similar companies on their AI journey. And it's never as simple as you just do 1, 2, 3 things, and then it works. But there are 3 things that I see emerging that are the high-order bits for how they were able to pull this off. That sets the successful AI ROI companies apart from the ones that haven't still gotten there. The first one is create a culture of AI fluency in the company. And Sebastian talks about this in his tweet. But at the end of the day, there's a ton of things going on here. But what I've seen work really well is, okay, leadership sets an example. Leadership empowers people, employees in the organization, enables them to use tools, but does not force down, top down, force them to use it. Instead, you have this bottom-up adoption, intrinsic organic adoption of AI tools that creates this culture of AI fluency in the organization. So that's the first one. The second one that Sebastian talks about in his tweet says it really eloquently, which is, if your data landscape is fractioned and fragmented, it's very hard for an LLM to make sense of it. And so they started looking at their data and exploring a number of key concepts. What of our data is actually valuable? What is inconsistent? What is incorrect? What is contradicting? And most importantly, why is it like that? of course, no one sets out intentfully wanting their data to be inconsistent and contradictory, but why did that happen? And then he goes on talking about how they were inspired by Wikipedia, which of course has problems, but it's chronicling all of humanity's knowledge and capturing that in a graph, collaborative across the entire globe. And then he mentions how a company introduced him to, in his words, the beautiful world of graphs. So AI has a very hard time operating on fragmented and inconsistent data, which makes sense. It's hard for us as human beings if you have 3 versions of a customer and they're all inconsistent, right? It's very hard for us to make sense of that, and the same is true for AI. But if you connect up your data, and Klarna connected most, if not all of their data, but you can start with 1 or 2 or 3 systems, all of a sudden you have a consistent and coherent backbone that works really fantastic for LLMs, for AI to make sense of. So that's number 2, connect your data. Number 3 then is, once you have this, you layer AI native tools on top of the knowledge graph. He talks about, okay, this was really interesting, but more importantly, we started seeing serious productivity gains, and he connects Cursor as one of the powerful front ends to this knowledge graph back end. Okay, so you've connected your organization's knowledge into this knowledge graph. What we see people do is they layer one of 3 things on top of it. It is agents, it is AI native tools like Cursor, typically through MCP, the Model Context Protocol, and then thirdly, AI-enabled applications on top of that knowledge graph. So 3 things: create a culture of AI fluency, connect your data, and then layer AI native technologies on top of that. Out of those 3 things, I am biased in all this, but I think most would agree that the most important one is number 2, which is make sense of your data. And this is where I've spent 20 years of my life, so let's double click on this a little bit. Okay, so let's take a step back and talk about the world of data, and do that from the perspective of analogy. We're going to look at the evolution of web search. So everyone here in this room, everyone here in this audience knows that the most popular web search engine today, of course, is Google, but it did not start out that way. In the early 90s, there were tens of web search engines, and they had names like Lycus or AltaVista or Yahoo or Excite or Hotbot and like all these kind of things, right? And they all did exactly the same thing, which is technically called an inverted index, where you look inside of each document, you find, are the keywords that I'm typing present in that document? Let's serve that up as a search result. That led to what some people call the AltaVista effect, which is that no matter what I searched for, I get too many search results. When I first got onto the internet in the early 90s, actually many of the terms that you search for had 0 answers, right? Then 5, 6, 7 years later, anything I searched for had too many answers, and the most relevant ones was like hit number 998, right? That was the first era, the full text era of search, and it was powerful, but with a lot of limitations. Then, of course, enter Google. This is Google's first press release from June of 2000, where they brag about indexing 1 billion URLs, but they also talk about the secret sauce. The secret sauce called PageRank, right? Which is this really powerful invention where they said, you know what, we are going to use the same technology as AltaVista and all these other folks, but we're going to rank the search result based on where they sit in the graph, where they sit in the web. If a lot of people link to it, that means we're going to pop it high up in the ranks, right? So they moved from this, we get too many hits, into the top 10 hits that matter. And the number of time people had to go to page 2 was very, very small. This was the PageRank era of web search, which lasted for over a decade, until 2012. When Google wrote a blog post, which I love both for the content of the blog post, but also very much for the title, introducing the knowledge graph, things, not strings, where they said this is the biggest innovation we've done since the invasion of PageRank, and we're going to move from what we graph geeks call a single relational graph, where a page can only be connected to another page through one type of relationship. We are linking together. From a single relational graph to a multi-relational graph, where we have multiple types of relationships. The knowledge graph, we all know what it looks like visually, because when we search for Las Vegas, for example, there's a panel. There's not just all the strings, all the links popping up, but there's a panel describing the concept of Las Vegas, right? And if you look at that panel, it has a bunch of metadata and unstructured data about it. This is what it looks like visually. On the back end, it's backed by a knowledge graph, which has Las Vegas as a concept. We call them nodes, which is connected to other concepts. It's located in the Mojave Desert. It's located in the state of Nevada. The state of Nevada has a governor, right? And this is located in the USA, and it keeps connecting to all these other types of data concepts, right? We call the rings in the graph world nodes. We call the arrows between them relationships. And both nodes and relationships can hold these key value property pairs. A knowledge graph. This ushered in the era of the knowledge graph, which lasted for another 12 years until last year. Because what happened last year? Last year at Google I/O, they talked about their next vision for search on the web. And it looked like this. You can see there, I mean, maybe you can't see what it says, but it's a classic travel agent example where someone is typing in natural language, or most likely speaking natural language, to the search engine, and you get a result back. Sorry, you get an answer back instead of just a list of links, right? This, of course, is backed by an LLM, that we all know, but more importantly than that, it's backed by this, right? It's backed by their knowledge graph. This is ushering in the GraphRAG era of search. GraphRAG. So GraphRAG is an important concept that we're going to spend a little bit of time on. What is GraphRAG? So GraphRAG is very, very simple. It is RAG where on the retrieval path we include a knowledge graph. So that was a simple sentence to say. How many in here knows what RAG is? Raise your hand. So probably half the audience or something like that. Okay, quick primer on what RAG is. So let's say we're building an application. Let's say we're building a customer service bot type application. Someone is asking a question, like what we want the application to solve is someone is logging on, they're asking a question. We've loaded up our data backend with all the customer support articles that we've collected over decades of running our company, right? And we want to be able to have the LLM, have the application answer that question using an LLM. Okay, so there's some kind of question that they ask. We generate an embedding version of this, a small vector version of that question. We use probably a vector database to find similar documents based on that vector search algorithm, find similarity of documents. We get a few documents back, 5, 10, 20, something like that. We hand them off to the LLM along with the original question from the user, right? We say, answer this question, dear LLM, using these 28 documents that I found for you, right? Answer the question, and then we hand that back out to the user. RAG. So turns out that I think intuitively for all of us, the quality of the answer back to the user is directly proportional to what documents we found across the 1,000 or 10,000 or 100,000 support articles that we've written. Okay, so that's basic RAG. What is GraphRAG then? Again, RAG, where on the retrieval path we use a knowledge graph. So it looks very, very similar. We have the same application, same question. We generate an embedding version of that question. We use vector search to find those initial documents, but remember, now we have a knowledge graph. So we know how those documents are linked. We know which authors have written those documents. We know that maybe this particular author tends to write the very high quality answers. We know that they relate to certain products. So if our user is asking about a specific type of product, we can narrow down and only find the documents relevant to that particular model, right? So what we get back here is the top 10 documents, and I'm using 10 as a metaphor because it might be 100, it might be 5. You need to check that with your particular LLM. But it's very similar conceptually, if you recall, to what Google did to the web, where we used to just search the entire web and get 1,000 back. And now we use the graph to rank to find the top 10 blue links and hand those off to the LLM to give us an answer. GraphRAG. Okay, so what are the benefits of GraphRAG? We've now been at this for about a year and a half. We coined the term GraphRAG as an industry about a year and a half ago, right? And what we've seen now, we have a lot of evidence for what the pros and cons are with GraphRAG or over normal RAG. The first one is higher accuracy. I think this one is intuitive to all of you now that we made the analogy over to the web, right? And it's been there's a very robust body of academic research showing that if you use a graph, in addition to vector search, it gets much higher degree of accuracy, anywhere from 3x to I've seen more recent research showing even more higher accuracy. So that's the first one, higher quality response back out. The second one is more counterintuitive, but that one is super, super powerful. So what this one is, that it turns out that once you've set up the knowledge graph, it's actually easier for your developers to build on top of a knowledge graph than if you have a vector database. And this is a literal quote, actually from an anonymous AI engineer, but actually I can now say that they worked at Klarna. So this is about a year and a half ago in the early parts of their journey where they had written an application, they call it internally their cache, and they ported it from a popular vector database to Neo4j. And they said that, you know what, thanks to the graph nature of Neo4j, most of the operations yield better results. We can store embeddings and calculate similarity at a database level. Getting related actions is as simple as just navigating the relationships between nodes, right? And this is the most powerful one. The application, the data in the application can be visualized. I can see it. I can touch it. I can feel it. It's not just this black box of vector calculations. And look at the parenthesis at the end. That's my favorite part of this. I actually already fixed a couple of bugs just thanks to this. That's really powerful. So let's double click on that a little bit more. If I wanted to express a concept in vector space, let's say that I want to describe an apple in vector space, right? It looks like this. Or maybe this is a train, or maybe this is Emil, like we don't know, none of us know, right? Vector space is very powerful, but it's used for calculating cosine similarity and how proximity in some Euclidean space. If you represent that in a knowledge graph, you have an apple, and an apple is part that grows on a tree, it is a fruit. You have all kinds of characteristics that when you look at it as a human being, you can make sense of it. And let's remember, this is not one or the other. The powerful thing with GraphRAG is that you use both in combination. So that's the second benefit, easier to develop. The third one is thanks to this visual explicit nature of the graph, you get both explainability and governance. So all of a sudden, inside of this explicit data structure, you can say that this customer service rep can access the phone number of my patient, but cannot cannot access the medical records. That's another role called doctor can only access that. That you cannot do in vector database. And there's a couple of quotes here. Analysts needed to dissect exactly how the AI reached a particular conclusion and recommendation. That's the first quote, right? That's really powerful. All of a sudden, you understand why you return these particular documents. And if you pair that up with some of the mechanic interpretability that, in particular, Anthropic has spearheaded inside of which explains the LLM, right? You have the two sides of the coin that leads to an explainable AI system. This, our customers in financial services and government and insurance and regulated industries, they really love this. That's a third benefit. So higher accuracy, easier development, and then third, explainability and government. Those are the three core benefits we've seen now after a year and a half of building GraphRAG systems with our customers. This is something that we've seen broadly in the world. It's not just Klarna. I threw a couple of examples in here, but before that, here's what some of the analysts are saying. Forrester is saying that Gen AI and knowledge graphs is a match made in heaven. Gartner, not to be outdone, is saying that it's the missing link between data and AI engineering. Last week, I was at one of our own conferences in Copenhagen, and before that, this is from, I guess GTC is next week. This is GTC a year ago, where Jensen Huang talked about like his vision of an agentic future, where he talks about 3 core data sources, right? Relational databases, vector data, and knowledge graphs. So last week I was at our own conference in Copenhagen, and 2 companies were talking about their own journey with knowledge graphs and AI. Novo Nordisk did not, like Klarna, start out by connecting all of their information, but they said, you know what? All the knowledge around our research, we're going to take that and we're going to connect that up. This is all the scientific literature that they've authored internally, but also all the academic, like the relevant academic articles from the outside. They put that all in a knowledge graph and make that available for scientists to be able to chat and explore. And Green Cargo is it's a cargo railway company that has built out a digital twin of the entire railway system in all of Europe. And on top of that, they're using an LLM so they can talk to it and understand where the trains are going and signal errors and things like that. 2 examples of companies that are early but successful in their journey towards knowledge graphs and AI. We have done this with a ton of customers, but the core platform has been used now for 10+ years. Here are some examples. 84 of the Fortune 100 is now using Neo4j, not just for AI, but for the core use cases that we've been at for 10 years, right? And you have an example here of some of the verticals. Like every single one of the 10 biggest banks in the US are Neo4j customers. Every single one of the 10 biggest car companies in the world are Neo4j customers. 8 of the 10 biggest retailers, 9 of the 10 biggest pharma companies. This platform is trusted by some of the world's biggest companies to run their most mission-critical systems. I was talking to someone else yesterday. There's so many examples in AI today where there's a benefit to be new, young, 3-month-old, 6-month-old, like 1-year-old, startup year old, right? With a database, you want to have been around because that proves that you're robust and you can stand the test of time and production quality, mission-important, mission-critical systems. So that's the high level of knowledge graphs and AI. If you think this is interesting, pull up your phone. Here's the QR code. You can go to our neo4j.com/generative AI. You can sign up. We have a free tier of our cloud service that you can just start working with for free. We've built out what we call a knowledge graph builder, which you can feed PDF files, YouTube clips, any unstructured information. It will build the knowledge graph for you, which is really phenomenal, something that just couldn't be done even a couple of years ago, right? If you want to learn more about the Klarna customer story, take the QR code on the right, and on the left, Philip Rathley, who I saw here in the audience, CTO of Neo4j, wrote an amazing GraphRAG manifesto, which is a little bit of a longer version, text version of the talk that I just gave that you can read up on, send to your tech team, and so on and so forth. And with that, thank you so much for paying attention, and enjoy the conference. Thank you very much.